So in the last video, we talked about how to solve systems by graphing. And the examples that we did, we had two equations that crossed at a single point. But that's actually not the only situation. It's possible to have two lines. I lost track of what I was going with that. It's not the only possibility. So let me give you a, for instance, okay? So what would happen if we have two lines that are parallel like this? You know, if there are two lines that are parallel, they're never going to intersect. So right here, when they cross at one point, this would be the solution where they cross. But what happens if they are parallel? What happens if they parallel? They don't cross. So since the solution is where they cross and these aren't going to cross, we would say these have no, this system has no solution. Okay. And then the third possibility is where one equation is actually a multiple of the other. So here is my first equation, and here is my second equation. One is just a multiple of the other. So these two equations are going to have the same graph because one is a multiple of the other. And so these two equations, they intersect, if you will, they cross at infinitely many points. So here, 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 at every single point on the line is going to be a solution to that system. So we would say infinitely many solutions. Okay, so these are the three possibilities. Most of the time you're going to have this where it crosses at a single point, but you should be aware that you could have two lines that are parallel, or you could have two lines that actually are the same line, in which case you have infinitely many solutions. So let's take a look and do a couple examples. So let's suppose I have 3x minus 4 is equal, 3x minus y is equal to 4. 3x minus y is equal to 4. This one looks pretty easy to put in slope-intercept for, so I'm just going to go ahead and do that real quick. I have negative y is equal to negative 3x plus 4, divide by negative 1. By the way, why would I say it looks pretty easy to put in slope-intercept form? I was looking at this right here. Yes, it's negative, but it is 1 as opposed to a 2 or 6 or a 12. So because this is 1, that makes it fairly easy to put it in slope-intercept form. So my y-intercept is going to be the 0.04. Remember, this is the y part of the y-intercept, so 0, negative 4. And my slope is going to be 3, or 3 over 1. So I'm going to go up 3 to the right 1. So 1, 2, 3 to the right 1, right there like that. And I kind of try to do a better job than I did with making that a straight line. Okay. Now I'm going to change the color. Like I said, it's just easier when we're using, let's do orange. So I have 6x or gold, maybe. All right. So this one, it doesn't have a 1 here. So let me just go ahead and do plug in 0. Okay. So if I plug in 0 for x, this is going to be gone. I get negative 2y is equal to 12, or y is equal to negative 6. Okay, right there. Plug in 0 for y, so I have 6x. This is going to become a 0 is equal to 12, so x is equal to 2. Oh, golly. This is where I wish I had. Oh my goodness. I really made a mess of it. All right. That's supposed to be a straight line. All right. And if you notice, these two lines are parallel, or at least they were supposed to be before I totally messed up this line. Okay, so these two lines are parallel. That means they are never going to intersect. So we would say there's no solution. Another way of saying no solution is with what we call the empty set. So this symbol right here, the 0 with a line through it, is called the empty set. And another way of saying empty set is with two braces with nothing in the middle. Do not put these two together because that is not actually the empty set. It's one or the other. So any of those three, to be honest, I'm not sure. I don't think they do this. I think they do this one as far as multiple choice in your homework. All right, 2x minus 5y is equal to 8. This is a 5. I'm just going to do my x and y intercepts by plugging in 0. So I plug in 0 for x. I get negative 5y is equal to 8. Divide by negative 5. I get negative 8/5, which is negative 1 3/5. So negative 1, and so it's going to be a little bit more than halfway between negative 1 and negative 2. Now I'm going to plug in 0 for y. So I've got 2x is equal to 8, or x is equal to 4. All right, let's see how badly I can draw a straight line. Oh, did pretty good. Okay, we're going to change the color real quick. Pointer options, ink color. Let's do green. 4x minus 10y is equal to 16. Again, plug in 0. If I plug in 0 for x, I get negative 10y is equal to 16. And this will reduce to negative 8/5, which is negative 1 3/5. There we go, right there. I plug in 0 for y, and I get 4. There you go. And this one, as you can see, is the same line, which means infinitely many solutions. By the way, do not put the infinity symbol. What you're probably going to see is a set builder notation, and that would look like this. So our answers, it's going to be a set of ordered pairs, so we got to put x, y to indicate that our answers are going to be ordered pairs, such that pick one of the equations, it doesn't matter which. We're going to say 2x minus 5y is equal to 8. So we would read this, the set of all ordered pairs xy such that 2x minus 5y is equal to 8. Keep in mind this equation in here could be either one of these two. All right, we talked about the three different possibilities, okay, where it intersects at one point, where they're parallel, or where they're the same line. Well, when we have the three different cases, we have different words to describe those particular systems. So it's easier to see with a picture. When they cross at one point, we say that the system is consistent. So this word consistent means that the system has a solution, has an answer. Can be more than one, but it has an answer. So if you look at the parallel lines where there's no solution, we say it's inconsistent, where it's the same line, lots of solutions, we say it's consistent. So anytime the solution has an answer, one or more answers, we say it is consistent. The exception being where they're parallel and they have no solution, we would say it's inconsistent. All right, next, dependent and independent. So when it's easier to see where the exception occurs. So right here, when you have the exact same line, when one equation is a multiple of the other, we say that one equation depends on the other. The system, the equations are dependent, okay? If it's not the same line, we would say they're independent. So here's the thing, guys. Two of them are consistent, only one is inconsistent. It's the one that has no solution. Two of them are independent, only one is dependent. It's where there's an infinite number of solutions, where it's the same line. It's easier to remember the exceptions to the rule than it is to remember the non-exceptions. So if you can remember that no solution means it's inconsistent, and infinitely many solutions means it's dependent, you're good. You're good to go, okay? All right, let's check to see how we can actually figure out which case we have without actually graphing it. All right, so I'm going to go back to this slide right here. All right, clear all this out. Notice for this one, so we're looking for special cases, no solution or infinitely many solutions. So notice my two lines are parallel, but we know something about parallel lines. We know that the slope of the first line has to match the slope of the second line, okay? So if we have the situation where the slope of the first line matches the slope of the second line, this is actually a possibility. It's not guaranteed, but it's a possibility. Because if you look over here, the slope of the first line matches the slope of the second line. Slopes don't match. We've got completely different slants here. So if the slopes match, it's going to be one of these two situations, one of the two special cases. If they have exactly the same y-intercept, then they're going to be the same equation, infinite number of solutions. If they have a different y-intercept, it's going to be this case where it's no solution. So let me show you. Describe each system without graphing, state the number of solutions. We don't want to find the solutions, we just want to find the number of solutions. So what we're going to have to do is find the slope of this one, find the slope of this one, and compare them. If they match, it's going to be one of these two special cases, okay? If they match, then we check the y-intercept, right? So clear all this out. We're going to put this in slope-intercept form. We're going to subtract 2x and divide by -3. All right, so my slope is my 2/3, and my y-intercept is 0, -5/3. Okay, let's change the color so that we don't get confused on which equation we're doing. Pointer options, color, let's do red. So for this one, we're going to divide by 3. So my slope is 2/3. All right, so the slopes match. Okay, so it's going to be one of the special cases. And let's check to see if the y-intercept matches. All right, y-intercept is different. Slopes match, y-intercept is different. So here we go, clear all this out. My slopes match, but my y-intercept is different. So there's no solution. It's inconsistent, independent. No solution, inconsistent, independent. Same thing. I'm going to add x, divide by 3. So my slope is 1/3, and my y-intercept, 0, 2/3. Let's change the color of the pointer, or the ink color. Let's do whatever color this is. I'm going to subtract 2x. Divide by -6. So my slope is 1/3, and my y-intercept is 0, 2/3. All right, notice my slope matches. Slope matches, and my y-intercept matches as well, which tells me I have the exact same equation. So I have this situation right here. My slope matches, and my y-intercept is the same. So there's infinitely many solutions, consistent, dependent. Infinitely many solutions, consistent, and dependent. And one more example. And all right, so last example. Oops. Come on. Maybe we'll do this last example. My marker isn't working. There we go. So we're going to subtract 6x. My slope is -6, and my y-intercept is 0, 3. And so I'm going to subtract 2x. I'm going to be lazy and not change the color. And divide by -1. 2x plus 11. And my slope is 2. All right, slopes are different. We don't even have to check the y-intercept. The slopes are different. So slopes are different. That's this situation right here. We've got one solution, consistent, independent. So one solution, it's consistent and independent. All right, and that should, yes, there we go.